Hey guys, it's Edbert. Today, I'll be going over Netflix's new blog, which tells us how they keep track of their resource usage. By resource usage, I mean their CPU usage, disk space, and any other resource that they might rent from Amazon Web Services. They illustrate a system that integrates perfectly into the microservices architecture and keeps track of the flow of information from source to sink. The goal of this video is to demonstrate how I think and analyze engineering blogs about matters that are not even related to me. For those who do not know, I'm an Android engineer and I have been an Android engineer my entire life. So reading about big data and analytics is something that's completely foreign to me. And yet I'm going to take the effort and time in order to try and understand the technology stack behind this. In doing so, I hope not only do you learn something from this blog, but how to apply this to your future readings as well. Doing engineering blogs like this allows companies to keep their brand name alive, while also simultaneously sharing actual tangible knowledge with the developer community. And I firmly believe that you can learn a lot from these blogs even if you are not familiar with their technology stack. Every single tech stack and component has a very specific use and design case, and often these concepts translate from tech stack to tech stack. So without further ado, let's begin. Now I see this title, Bite Down, making Netflix's data infrastructure cost-effective. But I don't know what it really refers to. It could mean the cost of sending data to the end user. It could be how they measure their own internal analytics. Who knows? So, I'm reading the first section, and I see that they have a problem. Trying to balance budgeting their resources versus giving the team flexibility to do what they want to or need to do. I take a quick peek at the link, which links me to their company culture page, and it seems to very much emphasize individual freedom and respect for human decision over corporate limits. The end result is that Netflix decides to inform their teams of their usage and to do what they want with it, as this quote shows. Our efficiency approach, therefore, is to provide cost transparency and place the efficient context as close to the decision makers as possible. So, I move on to the first section, and I see a bunch of terms thrown at me. I see a lot of tech stacks, S3 Data Warehouse, Cassandra, Elasticsearch, and, as I so eloquently put it, I literally have no fucking idea what these are. I mean, I assume S3 is some Amazon shit right here. Cassandra, Elasticsearch, oh god. Okay, you know what, just for the sake of completeness, I should really look this shit up. God, I feel like an idiot. So, I begin the painstaking task of actually figuring out what they are. I limit my search to only the ones mentioned in the article, not the diagram, just to give myself a basic understanding and not get sidetracked. I look at S3 Data Warehouse and land on the Amazon page. The first sentence tells me what I need to know. It just stores data and that the data is stored in multiple databases. I see that it talks about tiers, and so I draw a diagram as to what each of those tiers are. As you move closer to the top tier, the closer to the end user you are, and the more active the data is. That is, the bottom layer is just data on a disk. The middle layer is the analytics engine, and the top layer is the actual analysis of the data. I scroll down and I see a reference to a data lake. I briefly read it and realize that a data lake is just a pool of unstructured data, whereas the warehouse contains all transactional and related data. To confirm this, I quickly glance over the chart as understanding a data lake is not within the scope of my search. But I get the idea that the data warehouse is meant to house data and read it in a meaningful way. Next, Cassandra. I read the homepage and see that it is a large, scalable database. I relate it back to the data warehouse that was previously mentioned, and guess that they are using Cassandra as their database as opposed to a MySQL. But this doesn't give me enough info on Cassandra, so I navigate back to a new page and look at Cassandra's pros and cons so I can understand what specifically it is used for. Cassandra is a scalable NoSQL database that transforms very quickly, can add files very quickly, and can be accessed very quickly. But it does not adhere to ACID principles. Now, I realize I don't remember what ACID stands for, so I do a Google search for it and break it down. I'll throw up the definitions on the board here, but suffice it to say I just needed a quick refresher of what ACID is. Once I understand that, then I realize Cassandra is mostly used just for accessing, storing, and being able to perform operations on a large amount of data without regard for accuracy or the state of the database. Latency goes up, and then availability goes up. Okay, so this is your trade-offs with Cassandra. Cool. And then another deal is data safety in the face of hardware failure. So it seems like it goes all the way back to consistency for Cassandra. For my search for Elasticsearch, I stumble across a blog that mentions exactly how Netflix uses Elasticsearch. I figured that, given the name, it was used to search and index logs. It also has auto-sharding and fast replication, which gives it this ability, which I thought was good to know, but again, not necessary for the blog. So, knowing all this, I can kind of understand how they handle their data at rest. They use S3 to store their data in some lake, using Cassandra as a database, and then Elasticsearch to search for particular items. Once I thought about the benefits of each one, I began to understand what this stack is used for. It's not highly accurate, but then again, when you have several terabytes of logs coming in by the second, it's probably not all that concerning. You'd rather trade a small amount of accuracy for high transaction volume, since even if there is a 0.1% hiccup, the sheer amount of data will probably cover that. And I assume that's what the point of the stack is. So now that we've put away the data at rest section, let's move on to the data in motion. There are 4 topics. First is Keystone. It looks like it is describing the whole system of handling data analytics, whereas Mantis handles operational use cases, whatever that means. I look at it and I really don't understand what they're talking about with Stream Processing as a Service, or SPAAS. I get down to the diagrams and it starts to become a little more clear. There is an event that gets passed around in what I assume is a microservices architecture. Once the job is done and gets processed, then it gets sent to the sink. The second diagram just outlines it in more detail, and based on what I see, it looks like Keystone will intercept the job after it completes and then use it to generate the data for analytics. I go to Mantis and ask how it's different from Keystone. While I understand its different use cases, I also want to know if they are just carbon copies of each other or not, instead of just targeting different things. However, it looks like Mantis is a platform that other devs can build applications on top of. At this point, I'm pretty confused and wondering what the exact core differences are between these two systems. I just kind of give up on figuring out the clear, plain English differences. How is Mantis different from Keystone? I mean, both of them seem to be generating data, but finding their differences is just way too difficult and not worth my time right now if my goal is just to figure out what the main article is saying. If anyone can explain this in plain English, please comment below. Moving on to Spark. I have some familiarity of it after doing a few machine learning courses on it in the past, but I don't need to be super knowledgeable about it. It looks like it is a large job data processing framework. I look into Sphinx and try to figure out when to use Sphinx versus Spark. On the surface, it looks like they're used for the same thing. It turns out, Sphinx is used for streams, while Spark is used for finite batch jobs. Sphinx is also faster. However, this leads to the question, why would anyone use Spark over Sphinx? The article does conclude that Sphinx is far superior. The only thing is that Spark has more legacy. Okay, that was a really long trek, but I vaguely understand the tech stacks, or so I think. Moving on, I see that they give us a diagram. They use the AWS billing as their data mine, and then use their tech stacks to monitor these changes. But I don't know what Amazon S3 is. Well, turns out it's just tools to manage data storage. Atlas captures the internal operation information of Netflix and allows for real-time operations on that data. It implies that Netflix doesn't own their own hardware farm, but rather rents it from Amazon. Which leads us to this image. I find it extremely interesting and scary that they can break down the cost per team for resources. Okay, and when you put it like that, you can actually begin to see what teams are profitable and which ones are not. That's actually kind of scary, man. Like, if you're just some... Like, let's look at this. Like, if you're just, like, here, like a manager, or you're an employee, you're gonna be, like, part of it. They can actually see how much you are worth to the company. Like, legitimately like this, on an atomic scale. That's kind of scary. But, I mean, I get why they do it, but holy shit. Okay, the next is the TTL section, or time to live. Looking it up, I see that time to live just stands for the number of hops a packet will take before it dies when traveling from source to sink. In the context of logs, it's just how long they decide to keep the data for. TTL is just meant to prevent circular travels and give packets a lifespan so they don't travel around infinitely and clog up pipelines. Using all this, they actually build out a dashboard with recommendations as to when to remove the excess or unused data. Data storage isn't cheap, and based on the dashboard, they will recommend when to remove items if they haven't been used in the last N number of days, or how frequently it's accessed, which makes sense. You don't really want to keep data from a year ago if it's not relevant, nor do you want it sticking around if you're never going to use it for a meaningful sample. To do all this, they need to figure out whether they want to do it as a time trend or as a snapshot. As I understand it, a time trend is just ran on all the data at runtime, whereas a snapshot takes a copy of that data at a point in time and then saves it, like a git commit. The article says there are two primary considerations that make time trends much more difficult to deal with than snapshots. If any of the data ownership changes, I assume this means if a team takes over that data, then the time trend will reflect this. Secondly, as the job is ran, the meaningfulness of it changes. The longer the job is run, the further away from the present time it is, and the less up to date it is. So, to recap, there are two categories of data for Netflix, the data at rest and the data in motion. The data at rest stack uses an Amazon data warehouse to store the data, a Cassandra NoSQL database to manage it, and then Elasticsearch to be able to search over it. It trades the ACID principles that are found in MySQL databases for less accuracy but more transactional volume, which is fairly common for NoSQL databases. For data in motion, it uses a combination of Keystone and Mantis to capture the data it needs, then uses Spark and Sphinx in combination to process it. The data is audited with Amazon S3, and Atlas is used to manage the time series data and extrapolate on trends in real time rather than snapshotting the data. Because it is time sensitive, it is important that these jobs run very quickly, and Netflix is willing to trade accuracy for time. Using all these, Netflix can maintain a fairly accurate record of their resource usage and determine which teams are using more or less resources. Using all that data, Netflix makes recommendations to the teams based on whether or not that resource consumption comes from the users using those services or their own internal platform. Those recommendations also tell teams whether they should delete certain data or not past its expiration date. So yeah, this is what we learned from the Netflix blog. If you like this video, let me know. If you thought I messed something up or you want to add some more information, comment below. Hopefully you liked this video. If you liked it, give it a thumbs up, like, and subscribe. And I'll see you all in the next one.